Here we are? Okay. Yeah, good afternoon. Thanks for your attention. I'm going back to technical things. I'm from company DMT in Germany, and I will give you a very quick, let's say, appetizer of some of our geo-services, what we have for the mining. The title was for underground mining, but it is not only for underground mining, it is also some for other mines. So at first I will give you a very brief company presentation, who we are, and then I have selected 3 examples from innovative geo-services from our wide range of services we have. I will tell you something about our core logging tool, Core Scanner. I will give you some information about what we are doing in mine water modeling, and I will show you a quick presentation of our shaft inspection systems, which are quite new and very effective. So you see, it is a mixed purpose, but I hope it is interesting for you, and you will be interested in. So at first, some information about who we are. So we are an international technology service provider in the field of natural resources, safety and infrastructure. We deliver independent technology services in different fields. Our group is headed in Germany, in Essen, that is in the traditional coal mining area where our roots are coming from. But we have today subsidiaries, offices in most relevant mining regions of the world. Some numbers about turnover, employees, and a little bit important, DMT is also expert body for a lot of things together with mining, especially with safety in mining. Okay, we have 6 business units. You see here, geoengineering, international mine consulting. That is maybe more familiar to you under the name and the logo of IMC, which is our, let's say, trademark for the mining consultant business, coke making technology, exploration and geosurvey, industry systems, and building safety. So I am from the exploration and geosurvey unit, and we are doing all the what we call geo-services: geophysical, geological, geotechnical, and geodetical. And in exploration and geosurvey, that are the markets we serve: oil and gas, mining, and other raw materials, and infrastructures. Of course, today I'm mostly linked to mining because we are on a mining fair, and we provide services in the following fields. So it is on exploration seismics, but also on other exploration and engineering geophysics, on geology and borehole survey, on surveying and geomonitoring, on hydrogeology and water resource management, and beside all these services, we have also a unit which is doing geoinstrumentation. That means that due to the specific requirements of some of our customers, we don't have the right technology available on the market, and then we decide to develop our own technology. And 2 of my 3 examples are presenting such own developed technology for solving specific problems of our customers. So here we are with the 3 things: the core scanner, something about water management and modeling, and the shaft inspection system. Let's start with the core scanner. If you see this chart about a project, a typical mining project, and how it is going forward, so you will have an increasing importance and an increasing number of drill meters, and so you will have significant costs associated with drilling, and that means it will help you if you have the data, the results from your drilling, which are urgently needed for your ongoing work with your mining project in a really proper way. And therefore, we have developed this tool, which is a high-tech core logging tool. It is a portable core imaging device for drill core image acquisition, for storage and evaluation of full and slab core, for furthermore scanning of whole boxes. The core will be rotated, and you will get very quickly the results. And I think it is the highest resolution available for an optical scan of your core. And the best way to explain how the technology works is to show it in a quick movie. So herein is where we are. Here's a camera in. So you put at first for a quick scan the whole box. It will be scanned in a planar mode very quickly. Then you can remove it and will take a single core, which is here now, and which will be rotated. And while it is rotated, it will be scanned in high resolution. So you get really a very high quality image of your core. So you see the highest possible resolution is 1000 dpi. And then you have a proper software package with the system, so you can add all single cores to the whole borehole and can put it in your computer. And you can do all the typical analysis on the core, what the geologist is doing. You can do it directly on your computer, structural analysis like you see here. So with a mean dip direction, for example, petrographical analysis, definition of minerals from the optical things at first. Okay, that's it. This small one. So we have different applications. We see digital drill core acquisition and storage, and structural analysis, petrographic analysis, derivation of geotechnical parameters. You can buy the system, but we are also doing services. You can lease the system, you can get service. We can scan your cores for the campaign if you like to do so. We can do training, we can do reorientation, and we can do also the analysis if you want. What I forgot, we are, of course, because the question is ever coming up, it is also possible to make a hyperspectral scan, and we are already working on opportunity to make also chemical analysis of the content of the minerals with the scanner. So, but that is under development, and I'm not in the position to tell you details today, but that will be available soon. Okay, so from geology and core drilling to mine water management, it is an important part of any mining is to deal with the water, because mostly water is a natural enemy of the mining activities. So during operations, in case of abandonment, or also in case of reopening, water is a problem. So during operation, you have to keep the water short. In case of abandonment, you have to have proper flooding scenarios, and in case of reopening, you have to dewater your mine. So we have a long-term experience and extensive knowledge in optimization of water management systems, safety scenarios, predicting of flooding and dewatering, monitoring of flooding and dewatering, prediction and monitoring of water quality development. We are using our own technologies. We have a special model philosophy with a box modeling and finite differences and finite element modeling. we are using a lot of specific flow laws for mine water models. We can do a very flexible discreditation, especially considering inclined faults, which is very important for the water. And we have really a lot of examples, most of course from Germany, but a lot from others. So you see here examples from South Africa, Spain, France, Germany, and Poland, where we have done a lot of projects and really long-term projects to the sufficiency of our customers. Okay, that was the second information on the geoservice. The third is on DMT shaft inspection system that is going now to mine surveying. So that is a field where I'm originally from. I'm originally a mine surveyor. And shaft inspection is really important because shafts are typically the bottlenecks of underground mines required for a 7 days, 24 hours operation. And it is requested mainly for safety reasons to do regular inspections, daily, weekly, monthly, yearly, often required by the authorities. Additionally, sometimes special monitoring is needed. For example, if the shaft is impacted by mining activities close by, and also you need information about your shaft as a basic for planning issues. Okay, shaft inspection is a difficult business because specific conditions for any survey are dangerous, risk to fall down, limited space, dust, water, darkness, and of course small time window for surveying. Nobody likes to have a surveyor in a shaft because the shaft is needed for other things. And that brought us to the point that some of our customers have the requirements for a safe, a fast, and an accurate shaft survey system. Fast means that the downtime for the full measurement is less than 1 shift. Safe means remote operation, no man in the shaft during the measurement. Safe means also for gassy mines, which is not so much a problem here in Scandinavia, but in other areas, Russia, Germany, Poland or so, where you have coal mines, methane gas, so it must fill the requirements concerning the presence of methane gas. And accuracy means some millimeter accuracy in local details and in absolute coordinates for 1,000-meter shaft, approximately 10 centimeter. So we developed two different systems for two different types of shafts. Typically for shafts under operation, you have a cage or a skip in the shaft. Therefore, we have a system which will be mounted on the cage, on the skip. But during the sinking phase of a shaft, or for ventilation shafts, or also for abandoned shafts, you have often the situation that there is no cage, no skip in. So you have an empty hole, and therefore we have also developed a system. In principle, both systems have the same components, but you see the layout is different. One is mounted on the cage, one is hang down on a wire and is run by a small truck. Okay, so I have to hurry up a little bit. My time is going. So at the end, I will mainly can explain with this small movie again about the cage-based system. So you see, 2 laser scanners will be mounted on the top of the cage and running in a profiling mode very quickly, and will cover in one round 10,000 single points. And now the additional devices will be mounted. One is this inertial measurement unit, which is needed for measuring the position of the system in the shaft, and this odometer is for the measurement of the depth. And now the cage is running with a low velocity of 0.1 to 0.5 meter, and so we will get a full coverage of the whole shaft, and I will skip it. I will only show you very quickly some results. So that is a direct result from a point cloud, millions of points. That is an unwrapping. You can see any details, single bricks, pipelines, guides, and so on. And of course, you can do a lot of CAD modeling with the data, with, for example, to measure automatically the distance between the guides, which is a very important safety issue. You can make cross sections. You can see the deviation of the shaft, or if there are some damages, and that is. Everything is very quick and very accurate, and this example from a shaft in Germany has shown that for reconstruction of new pipelines in the shaft, with the data, they save 2 weeks of installation time and a cost reduction of approximately 200,000 euro. And at that point, I will stop my presentation. If you are interested in more details, it's only an appetizer in quarter of an hour. Our booth is directly outside. It is 204. Go left, go right, and you will run on our booth. You're welcome to visit us and to get more information about what we are doing. Also some other things besides this. Thank you for your attention.